Namaste, welcome back to the Pragna channel, and you are watching AWS Cloud Projects for Beginner to Expert. And I don't think we should consider ourselves as beginners anymore because this is our last season, and we are doing projects as an machine learning engineer. And to recap, so far we finished 6 seasons. Each season we did the different kind of projects in a different role, and this is the last one. And I think we are going to do 13 more projects because we already did one. So today we are going to do project number 81, which is about setting up an ML environment, machine learning environment. So let's find out what this is about. Hey, thanks for stopping by. I need to get your opinion on the best way to tackle a challenge given to me by the city's mayor. Sure, what is the problem? The mayor wants to make the city a premier artificial intelligence and machine learning technology hub, attracting companies that will provide great jobs for our citizens. That's a great idea. Business problems across many fields are being solved using AI/ML. Yes, I agree. As the principal of the new AI/ML Academy, my task is to provide a learning environment for our new students so that they can quickly gain the needed skills. I myself need some guidance. Deploying AI/ML applications involves several steps. Fortunately, Amazon SageMaker helps data scientists and developers prepare, build, train, and deploy high quality machine learning models quickly. Tell me more. I heard AI ML involves complicated coding and can be difficult to grasp. Can my students start with one tool? Amazon SageMaker Studio is the first fully integrated development environment for machine learning that provides a single web-based visual interface to perform all steps needed for ML development. SageMaker also supports many common machine learning frameworks and application programming interfaces that remove some of the complicated coding. Many sample projects are available to help teach AI/ML basics. Can you walk me through the process of deploying an ML environment and running a sample machine learning project? Of course, I will, because I too don't know, so I'm excited to do all these projects, all 14 projects as a machine learning engineer. By the time we finish this project, we are going to learn how to deploy an AI/ML learning environment, familiarize yourself or ourselves with the SageMaker Studio IDE, then walk through a sample machine learning project. Okay, I'm excited about this. Are you? So let's hit accept and let's start this. Here we are, as usual, the video concepts, and these video concepts I don't think we have watched yet. So I would highly recommend you to watch each one of these videos. These videos are available in the playlist that will pop up here. Click on it, which will take you to AWS tutorials for beginners, and then search with these titles in those playlists and watch the video, and then come back and watch the rest of the project. Let's look at the steps involved in the architectural diagram. In this solution, developers use SageMaker and SageMaker Studio to quickly build, train, and deploy machine learning models. SageMaker domain consists of an associated EFS volume, a list of authorized users, and a variety of security application, policy, and VPC configuration. You can see all that here. SageMaker domain comes with SageMaker Studio, a Jupyter notebook, an EFS home directory, and a shell terminal. Jupyter notebooks provide an interactive computational environment to build and run machine learning operations. Jupyter documents contain the code for running operations such as training jobs. I think which is similar to the Databricks. SageMaker Studio provides a single web-based visual interface where developers can perform all machine learning steps. After running a job through SageMaker Studio, the trained model is uploaded to S3. To get an endpoint that can be used to test predictions from a model, developers deploy the model to SageMaker hosting services. These endpoints are fully managed and support auto-scaling. Real-time interference is ideal for prediction workloads that have interactive low latency requirements. These managed endpoints help developers query data without managing their own set of EC2 instances. An AWS Lambda function with a JSON payload queries the inference endpoint. The endpoint returns the prediction results. Okay, nice. For increased performance, developers can create additional inference endpoints that use more powerful instance times. Okay. This is, I guess, the introduction for us, at least for me, because I have no idea what all these do. As part of the practice lab, we are going to deploy SageMaker domain that includes Studio, and then we'll clone a GitHub repository of sample machine learning projects. Then we'll upload and walk through a sample machine learning project, configure and test an AWS Lambda function to call a SageMaker endpoint. Awesome. And we have already used Lambda to call several services, including what is that service? Recognition recently. I think in the last project we have called uh, what else we called? We called step functions and we called Redshift stored procedures. We called a lot of services using Lambda. SQS, SNS, you name it. And as part of DIY, we will create a new inference endpoint using an instance type of M5X large. This will be part of practice lab goals M4. This we will create a new one. Then we will rerun the Lambda function using the newly created endpoint. All right. So let's go ahead and start the practice. Let's start the lab. And it looks like there are two files to be downloaded. Let me download those to my desktop. Okay, let's click next. I already downloaded them. So let me do one thing. SageMaker, using SageMaker, data scientists and developers can quickly build and train machine learning models and directly deploy them into a production ready hosted environment. So let's go ahead and open a SageMaker in North Virginia region. And then let's click Setup SageMaker domain. SageMaker domain consists of an associated EFS volume, a list of authorized users, and a variety of security, application policy, and VPC configurations. So all that is part of this one. So let's go ahead and set up SageMaker domain. Then we are going to select setup for single user, which is quick setup, because this is going to be used for the lab. If you need more control over your security and network settings, the standard setup allows more customization options, which you can see here. It will take up to 10 minutes for the domain to be ready. If you see an access denied exception warning regarding SageMaker portfolio, it can be safely ignored. When you onboard to Amazon SageMaker Studio, SageMaker creates an EFS volume for your domain that is shared by all SageMaker Studio users in the domain. Okay, so let's stop it here and go ahead because it's going to take 10 minutes and I don't want to wait 10 minutes. So let's go ahead and create it. In the meantime, we can go back and cover the remaining steps. Okay, usually I don't look at few steps and come here. I usually go through all the steps and then do it, but since there is a 10 minutes, I don't want to make Amazon SageMaker, create a domain. Okay, we will click up. You can click that, or you can, I guess, go to the studio or create a SageMaker domain. We will come here, setup, and they already said it will take about 10 minutes, so I'm fine with it. I'm not worried about it. So let's go back and continue with this one. After the domain is ready, it might take a few minutes for the console to display the created user profile. If you do not see the newly created user profile after a few minutes, refresh the browser page. SageMaker Studio provides all the tools that you need to take your models from experimentation to production while boosting your productivity. You can see here, right? When you click on launch, you can see the studio right here. That's what they're talking about. Okay, so once we click on the studio, you can see all these Jupyter Lab, R Studio, and I think this, what is this? Studio CLI? I don't know what that is. Studio Classic? I don't know. In the applications panel, click Studio Classic. Yeah, that's what it is. Under status, I think right here, review to ensure that the classic application is running. If the Studio Classic application is stopped, user action, click run. User action, where is that? I guess somewhere. Or where here? In a single unified visual interface, customers can perform the following tasks. Write and run code in Jupyter Notebooks. Build and train machine learning models, I think using RStudio. Deploy the models and monitor the performance of their predictions. Track and debug the machine learning experiments. So pretty much you can do everything using this one. On the top navigation bar, click File to expand the drop down menu, which is that one. Then let's click New. And we already downloaded some files. I guess we will upload them here. When SageMaker Studio first opens, it shows the Launcher tab that you can use to quickly get started. SageMaker Studio extends the Jupyter Lab interface. Okay, so it just extends the Jupyter Lab interface. Okay, and we already have so much documentation here. If you are interested, maybe I will go through them later on. Okay, so new and then terminal. Looks like we need to click the terminal here. Choose the terminal from the new because we can create so many of the new types. In the terminal window, at the command prompt, run the following commands one at a time. Okay, who am I will give you the username, and pw will give you the present working directory. ls will list all the content in that particular directory, which is nothing right now. And then you are using git clone command to clone the git, which this lab is already hosting in that particular repository. And in the left sidebar, click the file browser again to ensure examples folder is displayed. Okay, where is that? Yeah, I guess here one. File, then click on that, then it will show you the examples folder. Looks like there is already a folder named examples because that's what we cloned, right? Okay, it downloaded. The download might take a couple of minutes to complete it. When you open a terminal session in SageMaker Studio, you are logged in as the SageMaker user in your home directory. Linux commands are available to be run. Again, right? SageMaker is installed on a Linux instance. In the file browser, open this one, the Git that we cloned, and under it you can see there are so many examples. Review the large number of sample ML projects provided. Although we downloaded these example machine learning projects in this step, we use our own curated example in this practice lab. So we are not going to use any of this. Interesting. To quit the terminal, run exit. In the file browser for the Amazon SageMaker examples folder, click the folder icon. I guess that one. This takes you back to the home directory. Now let's go to the next step. Jupyter notebooks are structured data that represent your code. Metadata, content and outputs. When saved to disk, the notebook uses the extension .ipynb and uses a JSON structure. Okay, now in the file browser, we are going to upload a file that we already downloaded, which is nothing but the Jupyter notebook. We downloaded it, which is called MXNet sentiment analysis with Gluon. Okay, let's upload that. Okay, after all this, let's upload the notebook. You can use SageMaker Studio to download sample machine learning projects from GitHub and then use the launcher window to get started or upload your own predefined Jupyter notebook, which is what we are doing right now. Okay, open the context menu for the notebook, then choose open. Right click on that and click open. That's what we are doing. In the pop-up box for image, choose data science 3.0. So we are going to choose what image, data science 3.0, and kernel or runtime we are going to choose Python 3, and the instant type and startup script keep the default values. We are not going to touch them. You can use the startup script feature to bootstrap certain components to help users quickly get started. So when you do this behind the scenes, I think it's been an easy to mention, right? So then you can use a script to bootstrap it as part of the user data. To collapse the file browser, in the left sidebar, click the file browser icon. At the bottom of the page, review the status bar message which indicates that the kernel is starting. So when you click on that, I think at the bottom it will show starting. Useful information about the kernel is displayed in the bottom status bar, initializing, etc. Go to the next step. Jupyter Notebook is composed of different cells. Use markdown cells to provide information or instructions to the user of the notebook. If you have used or learned Python, you would have already you know, you would have already practiced on a Jupyter Notebook. Okay, let's go back since there are certain things that take time. Let's go ahead and finish these steps. Let's see if this is even ready. Okay, looks like it is still. Choose your username, then choose launch app to get started. I think this is the username I guess they are talking about. Okay, it is ready. Launch Studio. Okay, here is the studio you can see, which is looking nice. Automatically build, train and tune models. There are so many examples. Jumpstart, code editor. We are not going to touch all of this right now. Okay, so as you can see, they asked us to click on Studio Classic. And is it stopped? It is not running. So they asked us to click run. It is in progress. I don't know how long it will take. Okay, it is still running. So let's wait a minute or so. That's fine. Let it start. While it is starting, let's see what else we have here. We have deployment, jumpstart, etc. You can see pretty much everything that we need are right here. Okay, so let's go back and come again because the status has to say running so that we can open it. Right now it's still starting, so we cannot do much about it. So let's go back and let's go next. Okay, so now we are here. Review the button status bar and wait for the kernel to switch from starting to idle. Idle means it's already set up. It may take up to 2 minutes to start. In the notebook, review the download, training and test data section. So you can see the code here. These are cells and this is the markup cell, which means it won't get executed when you run it. Only this code cells will be run. Markup is like disk for description and etc. So what is this doing? Make directory data, import boto3 and you are starting the S3 and you are downloading file from this bucket. I guess in this, yeah, we are downloading the file and I think you are putting in this particular folder. Same thing, you are downloading another one, then you are printing download complete. Pretty much this cell, that's what this is doing. So what we are going to do, we are going to run this one cell. You can click that cell and click run. It will only run that particular cell. You can run everything as well. This code cell creates a directory called data, imports some necessary libraries and downloads a train and test dataset that you use in future steps. You can run shell commands directly from within the notebook by appending a dollar to the beginning of a valid command. Okay, let's upload the notebook. Then okay, let's do that. And then the next cell, this is the first cell, this is the second cell, and you can see upload the data. What are we doing here? This code cell uploads the data to an S3 bucket for model training. Okay, so you can see we are importing S3 and session bucket, default bucket. We are setting up the bucket and inputs S3 uploader upload. What are we uploading? The data folder that we created, and then we are uploading this flower bracket means is the parameter, and that we are passing from here. Then we are putting it in this bucket in that folder. Okay, pretty much that's it. That's all that is doing. After a code cell run is completed, a sequential number appears in the brackets on the left side of the code cell. You can see 2. A code cell that is still processing is denoted with star. If it finished, a number, otherwise it will star when you are running it. Once you finish that, let's review the next cell implementing the training function. We can read here for more details and run a SageMaker training job. In machine learning, you train a computer to make predictions or inferences. First, you use an algorithm and example data to train a model, right? You need the data, you need the algorithm, so you will feed it and you will train it. Think of it as like training a person, right? That person doesn't know anything. So what will you tell him? Obviously, you will teach him some certain steps that he has to follow, and then you will expect him to do it again, and not do it again, but learn from it. Then you integrate your model. So once you have your model, you train the model, then you will integrate your model into your application to generate inferences in real time and at scale. So once you have your model, then you can apply that to other data, new data, and you expect predictions based on using that model. Okay, so that's what we are going to do. So this is the SageMaker training job that trains your data. Apache MXNet is an open source deep learning framework that helps you define, train, and deploy deep neural networks on a wide array of platforms, from cloud infrastructure to mobile devices. MXNet is highly scalable, which provides fast model training, and it supports a flexible programming model and multiple languages. So let me try to see if I can understand this. We are importing a couple of libraries. Okay, we are calling the MXNet, and then I guess it takes a Python script, which is the sentiment.python, which is already written. We are passing a role. It has to use how many instance? One. Instance type MX large, framework version, Python version, distribution, and hyperparameters. Batch size 8, epochs 2, learning rate. I don't know what those are. I guess we will learn about it. So let me go back. Let's see if our it is done. Okay, it is running right now. Now I can click on open. Okay, this is the Jupyter notebook still opening. Okay, it opened, which is nice. Looks something similar to the previous one, but it is not. Okay, so what are we supposed to do once we are here? You can check out the all these awesome things. If you click on this folder, it will go to that folder directory, launcher, etc. But let's go to the file. Let's click new. Let's click on the terminal so that we can enter certain commands. Who am I? It's not the, I think, is it Jackie Chan's movie? Who am I? You can see the SageMaker user. We are executing whatever the commands are, the training models, etc. PWD, present working directory. We are in SageMaker user. And ls will list everything which is empty right now. Okay, now since you can see it is empty, we are going to clone it. We are going to clone this particular repository into our workspace. Let's enter. They said it will take at least 2 minutes, but I highly doubt it because we are on cloud, or it might take. Okay, so once you clone it, it is technically downloading it here, as you can see. So if I click on this, double click, well, since it's still downloading, it's not showing, but it will show all the, I guess, models, different machine learning models, examples that will list here. You can see them here. Okay, nice. Okay, they have subdirectories again, marketplace, using data, classification, etc. You can see all those. Okay, we are not interested in all those. These are examples. If you are interested, you can go through them later on, but as they said, we are not going to use them. Okay, so now since we are good, let's click on this one, which will take us to the home directory. Because we don't want to upload our notebook that we downloaded. So instead, let's go to the home directory and let's click upload file. Okay, now this is completed. Once this is completed, let's go ahead and upload our notebook that I downloaded, which is part of the labs. So let me pause and come back. And I just uploaded this here just by clicking this upload files. Now right click on this, click open, which will open the notebook, Jupyter notebook. Here we are supposed to select data science 3.0, Python 3 as the kernel, runtime, and defaults for these two. We don't have any scripts. We'll be triggering instance type is that. Let's select it. So this will start the notebook. This is the reason I wanted to do them, because there is some starting processes. So let it start. And what did they tell us to look at the status? We can click on this and it will show you the status at the bottom right here. So let's go back to our steps and we'll come back. Okay, we ran that. Nice. I hope they will explain us what each of this is. Okay, they are not. Then let's run the next course cell. This step can take up to 10 minutes to be completed. Take a break or review the micro concepts. Go to the next step. Seriously, you want us to review? You are not going to explain us? Okay, since they triggered it, it is going to run. This is the micro processes concept they want us to look at. Gluon provides a clear conscious API for defining machine learning models using a collection of pre-built optimized neural network components. Developers who are new to machine learning will find this interface more familiar to traditional code because machine learning models can be defined and manipulated like any other data structure. Okay, so let's run this one, like fit inputs, all that. Review the full output. Okay, so let's hold on till here because again we have some 10 minutes window that will take. So let's go back and check what is going on with this one. It is still taking time. It's starting. So let me pause here for a minute and let me come back. All right, so this is done. As you can see, it's in ideal state. Now these, as I mentioned, are called markup cells. You can see that by looking at this. In this notebook, we train a sentiment analysis model on the Stanford Sentiment Tree Bank dataset. This dataset consists of movie reviews with one sentence per review. The task is to classify the review as either positive or negative. We download the pre-processed version of this dataset from the links below. Each line in the dataset has space-separated tokens, with the first token being the label 1 for positive and 0 for negative. Okay, so let's click on this and let's run it. How do you run it? You run it from here. Run the selected cells. So this will run, and it already ran. As you can see, if it is the number is displayed, it is done, and you can see the message printed download complete. We use the SageMaker uploader S3 uploader to upload our datasets to S3. The return value inputs identifies the location. We use this later when we start the training job. Okay. So now what are we uploading? So if you click here, this one created a data folder, and in this we downloaded both the train and test, and we uploaded that to another bucket because this is the Stanford's datasets we downloaded and we are putting them to this particular bucket and we named it inputs. We need to provide a training script that can run on the SageMaker platform. The training scripts are essentially the same as one you would write for local training, but you can also access useful properties about the training environment through various environment variables. In addition, hyperparameters are passed to the script as arguments. For more about writing an MXNet training script for use with SageMaker, see the SageMaker documentation. The script here is a simplified implementation of bag of tricks for efficient text classification as implemented by Facebook's fast text for text classification. The model maps each word to a vector and averages vectors of all the words in a sentence to form a hidden representation of the sentence, which is inputted to a softmax classification layer. Whatever they are talking, I have no clue. That is not the point for me. At least I hope if you are machine learning background, I hope you understand all that. But for me, I'm a data engineer, so I'm just doing this to learn the steps that are involved. For example, if somebody in my team asks me to set up this environment, right, I should be able to do it. At least I should be aware of what are the different things that are involved. And I'm trying to shift my career to machine learning, and also I'm just trying to see what are all the things that I need to learn, right? So For that, that is another reason. At the end of every epoch, our script also checks the validation accuracy and checkpoints the best model so far, along with the optimizer state in the folder checkpoints. If the folder does not exist, this checkpointing step is skipped. Now let's run the SageMaker training job. The next class, as you can see, allows us to run our training function on SageMaker infrastructure. We need to configure it with our training script, which is here. An IAM role, the number of training instances, and the training instance type. In this case, we run our training job on a single M4X large instance. So let's click that and let's run it. As you can see, there is a star, which means it is running. After we have constructed our MX next estimator, we can fit it using the data we uploaded to S3. SageMaker makes sure our data is available in the local file system. So our training script can simply read the data from disk. This step may take a while to execute. So as you can see, even this is done and it put these files inside those directories. So this is the one that will take time. And again, M is the model that was created here. Fit inputs, input is the data that we actually put here, which has both the train and test. Okay, train will train it, test will test it if our trained model is working or not. So let's me click and click run here, which they said it will take some time. Name inputs is not defined. I don't know why it is saying that, because we created it right here, didn't we? Didn't I run this? Oh my God. Okay, it's empty, which means I didn't run this. That is weird though. Is this not taking? Okay, it is not taking my inputs anywhere. So I'm fine. So let's go ahead and run this one. It's going to take 10 minutes. File not found. Which file? Sentiment.py. Why? So where is this getting accessed from? Sentiment.py. It's not in here. Okay, so am I supposed to run this again? Let's see. Okay, it's not. So where are we getting that from? Where is it trying to access it from? Is it supposed to read from my desktop? But how will it access the desktop? It won't. I guess when we uploaded this one, we might have to upload that as well. So let me go ahead and upload that. If you are wondering, this is the file that they gave along with the notebook. So let's go ahead and run this. And let's try to run the inputs. Okay, it is running now. So this one, let's see what it has actually. This is a Python script. It has a class called train and it takes these parameters. If length of house is 1, I don't want to understand this right now, but I'm showing you so that if you're interested, you can take a look at it. Yeah, I know, right? 500 line code. Anyways, I think this, I will use this as examples when I'm learning. Okay, you can as well. It is starting the training job, preparing the instances for training, downloading input data. As can be seen from the logs, once this is finished, our model starts off at 74% accuracy but gets better and better, ultimately achieving over 90% accuracy on the test set using the above hyperparameters. After training, we use our MXNet object to build and deploy an MXNet predictor object. This creates a SageMaker endpoint that we can use to perform inference. This step may take some time to complete. Okay, so while that is happening, let's go back to our steps, and we have already read this. So let's click next. Review the full output, review the training job completed message, something like that it will look like. Processing is completed when the kernel status go back to idle state or when the asterisk disappears from the bracket, which will be there. The training phase provides valuable metrics such as training accuracy, number of samples processed per second, as you can see, I guess this one, a summary of training job duration. Okay, this is the next one, predictor. This cell code deploys an inference endpoint that can be used to integrate client applications to get real-time predictions from input data. Now we train the model, all we have to do is supply it new data and try to see the inference. The inference endpoint is deployed on M4X large. Wait for processing to be completed. This might take up to 5 minutes. Go to the next step. So once that is ready, we can go to the next step and give it some data. This movie was extremely good, so it is positive. Plot was very boring, negative. This film is so slick, superficial, positive, negative, positive, I guess. Okay, so we'll run this next one. The input data for the inference endpoint is a string array of customer reviews. The output is a Python list of ones and zeros that predict the sentiment of the review as either positive or negative. The film is so slick, superficial, and trend hoppy. So it is a negative. I thought it is positive. Anyways, so it did that ones and zeros, and once it does it, that's it. Are we not cleaning it up? Did we not run that? Okay, let me review the output. Scroll down to the next code cell, review the output, go to the next step. On the click file, choose logout. When you log out, you are taken back to SageMaker domain page. Okay. Now you are here back again. Inference is the process of making predictions using a trained model. Okay, inference. Okay, that is nice. So we can go to our inference endpoints, and then, I mean, once that is done, I guess this will show up here. You can deploy your model to SageMaker hosting services and get an endpoint that can be used for inference. These endpoints are fully managed to support auto scaling and can be deployed in multiple availability zones. Okay, so in the endpoint settings section, under type, review to see the real-time type. Under name, select and copy the provided endpoint name and then paste it in the text editor. You will use this endpoint name in later step. Real-time inference is ideal for inference workloads where you have real-time interactive low latency requirements. Now let's go to S3 again. Model artifacts are the results of training a model by using an ML algorithm. The inference code must be packaged in a Docker container and stored in ECR. You can package model artifacts in the same container as the inference code or store them in S3. By creating a model, you tell SageMaker where it can find the model components. This includes the S3 path where the model artifacts are stored and the Docker registry path for the image that contains the inference codes. And that is called the SageMaker US bucket. And machine learning, and M is not a vowel. I don't know why there is an. A machine learning model is a mathematical function that generates predictions by finding patterns in your data. Okay. If you had issues during the lab and had to start the process over, you might have multiple folders named MX Next Training. I don't think we had any issues. The process of training an ML model involves providing an ML algorithm, that is the learning algorithm, with training data to learn from. The term machine learning model refers to the model artifact that is created by the training process. And then let's download that model that it trained. I mean, obviously, once we finished all the steps. So let's go ahead and check what is going on with that, shall we? Okay, it is, okay, it did run. No GPU is detected. Normal if no GPU is installed. Invoking user script, training environment, hyperparameters, input directory, parameters, more parameters. I think they said it started at 70%. Where can I see that? Mm, I don't know. Okay, so here we are. Did it finish? Yes, it did idle. It is finished, or we can even check here. Star, or it is still running. Star means it's still running. Never mind. I don't know why they asked us to check the idle then. Okay, it's still running. Accuracy 90%. I think we should be good. Let's see. Okay, this is what they mentioned, right? So the starting itself, the accuracy it is 73.8 training. That is very good. Usually it won't be that, but it is good, 73%, and it increased with the more data you give, the more accuracy it gets. So 90%, and it's still running 90%, etc. But I guess is it still running? I think yeah, it's still running. Let's wait. So let's go back. Let's download that model. Okay. And once you download and unzips it, it will have the vocab JSON, model JSON. Inside the code folder, review the sentiment.py file in your text editor, which we already seen earlier. This is the training algorithm written in Python. The model.params file is in binary format and therefore is not human readable. I think this one. A deployable model in SageMaker consists of inference code, model artifacts, and AWS IAM role that is used to access resources and other information required to deploy the model. Okay, now let's go to Lambda that will trigger actually this particular SageMaker model. Lambda, we already know, we don't have to understand what it is, and there is already a Lambda function that is created which will trigger the machine learning. After you deploy a model into production using SageMaker hosting services, your client applications can use the invoke endpoint API to get inferences from the model hosted at the specified endpoint. We will review it. This should not be a problem for us. Okay, they are already showing it. They are triggering the SageMaker here, and then the test file, we need to send it the file, right? Since we are preparing this, we are just telling it the string IO, and the payload get the value from this test file, and then the response is what? Client invoke endpoint. Remember the endpoint that we copied earlier. We will paste it here, I guess. Content type is text CSV. Body is the payload. That is the accept. After you create a Lambda function, you can configure additional capabilities for the function such as triggers, network access, file system. We already know about Lambda, so that's fine. Edit it, replace the endpoint name which we created as a variable. Click save. And let's test it by clicking test, mark test. It doesn't matter, it doesn't take any input, and as you can see it gives 0 1 0. Don't we have 5 of them? What text did we copy paste it? Oh, it's already there. Okay. The movie was horrible, obviously. Zero. This movie should be awarded Oscar. Seriously? One guy says horrible. Okay, this is done finally. How much accuracy though? 90. Okay. Okay, you can see training seconds, how much billable seconds, how much it took, etc. That is good. We are done after training. To build and deploy an MXNet predictor object, this creates a SageMaker endpoint that we can use to perform inference. So let's click that. Let's run it. I think they said it will take about 2 minutes for this one to get executed, I guess. Okay. So once that is done, when we run this, what are we doing? We are just testing some more data or inference from that model using this inference one, right? But what are we doing with Lambda? We are doing the same thing, but not from here. But in production, you won't go and execute it manually, right? When you're testing it, developing it, you will do something like this. But in production, you will do it from another tool like Lambda or some scheduling tool or step functions, etc. So that's what that Lambda function is all about. So now let's see. Yeah, it will give ones and zeros as you can see. Let's give it a minute and then we can execute this. Let me go back. I'm just thinking. I'm just thinking. Uh, what am I thinking? Yeah, I think pretty much that's it. No, no, I'm not thinking. I don't know why I'm saying I'm thinking. Okay, I think pretty much that's about it for the test, which is awesome. I mean, there are so many things that are there for us to learn. I don't know what is your background, but my background I already told you. So let let us get this finished because we still have to do the DIY. I know I think DIY how we can change that. I think this is what they want us to change, right? The instance count and etc. predictor inference. I think they want us to create another one. Okay, they said 2 minutes. I don't know why it is taking forever. In the meantime, what we can do is let me go to the uh, Lambda. This is the Lambda function. Okay. So as you already know, this is the main function, and I think that's the code. I think I already explained. I still don't know the endpoint because it's sta- it's just getting created. So once it gets created, we can go back to where is it? I don't think it's here, is it? No, it is not here. That showed us to go to the inference endpoint from somewhere. Okay, this is done, but I'm just wondering where the inference endpoint is. We'll go back. Let's click run, and it gives us accurate data, which is good. Delete endpoint, we are not deleting the endpoint. The reason being, we are going to use that endpoint with our Lambda. Okay, so that is good. If I click home, yeah, I guess it should be here, right? Yeah, endpoints. Yes, and I need the name, right? Not the ARN. So let's copy it. It is in service, which is good. Okay, we can leave it there. Results are cached. Good. Okay, so once we do that, we copied it. Let me paste it on my notepad. Let me go. I mean, these projects are taking longer. I thought it would finish faster, but no. Okay, let's go ahead here. No, not this one. Come on. Environment variables, edit it. Let me place that here. Save it. Okay, but we also need to go to S3 and what was it? I think it's the SageMaker. And we only ran it once, not multiple times. I guess we need to pick the latest one, and it's this one, and I can download it. Let me try to unzip it and open. Yep, that file contained those files that they showed us, so we are good. And what is next? Let's go here. We modified that. Let's test it. I don't think there is anything. Let's create a dummy. Since it doesn't take any input, it doesn't matter what you use. So if we test it, it's supposed to go and use those three values. Horrible 0, Oscar 1. I did not like the ending, obviously 0. So, which is what it showed us, right? 0, 1, 0. I think pretty much that's about it for the DIY though. We are not done. Let's go. Sorry, for the practice lab, let's do the DIY. Create a new inference endpoint using ML M5 X large. It is very easy. We already know where to do it. Let's go predictor deploy count 1 and they want M5 X large ML M5 X large. Okay. Rerun the lambda function using the newly created one. That is easy. So let's select this, run this. So it is going to take some time again. So I'll be back. All right, it is done. And if I run this, I don't know which one it will use, but let's run it. Okay, it is running. If I go here, I should see, not here. If I go here, I should see another one. Yes, which is this one. So let me copy that and let me, I think is that the endpoint name they're asking? Yeah. But let me go here and run it using Lambda as well. Configuration, edit, paste it, save it, done, code, test, and it ran successfully. Okay, so let's go ahead, give them the good news, validate, expecting a green, green, green. Yes, green, good news. Okay, I think I'm going to enjoy this season more than any other season because in the remaining seasons, I know at least 60% of the stuff that we did. But this season, whatever we are doing, I'm completely like not just the practical way to do it, even theoretically, I have zero knowledge about it, so I'm enjoying this. Thanks for the guidance. You're welcome. Choose your reward. I will pick this. Looks like it has a swimming pool. I like that. But trust me, I'm enjoying this. Most of the stuff I don't know, but at least, as I mentioned, from the technical standpoint, I can, when somebody talks about SageMaker now, I know what it constitutes. Whenever somebody says SageMaker domain, I know the tools, etc. I can talk. I can contribute something to that conversation. So that's what I'm excited about. That's what I'm here for. Because it's not like, at least I should know the theoretical knowledge, otherwise doing this won't give me anything. Since I have theoretical knowledge about some things like networking, I was able to grasp at least 80% of it. But here, nah, I don't think so. Anyways, so that's about that. Let's go ahead and zap some drones. And as you already know, this is going to be a competition between you all and myself. So let's see. There are going to be 5 questions that they are going to ask. Pause the screen right now, answer it, then I'm going to answer. Let's see whose answer will be correct. And then at the end of 5 questions, I will have my score, you will have your score. Post both the scores in the comments. Then whenever I upload this video, I will take a look at your scores and will be like, okay, I lost, you won, or you won, I lost. Or it's the same, both are same. Which fully managed AWS service helps build, train, and deploy machine learning models? It's SageMaker since we just learned about it. Easy one. 1-0. All right, 1-0. 1-0. Amazon SageMaker Studio is a fully integrated development environment for machine learning. Sure. 2-0. 2-0. 2-0. All right. Which API call would be used to query an Amazon SageMaker inference endpoint to get a prediction by using Lambda? Huh, interesting. Um, it's either one of these. Ah, man, I will go with. I think I will go with inference. Oh no, it's invoking. Can I change? 2-1. Okay, this is anyways, this is wrong. I should have picked the other one. But which cells in Jupyter Notebook provide a complete computational record of a session? Um, what? I don't know what, Jason. I will just copy. Markdown gives you explanation. Code will give the code. Raw output will tell you what you are running. 3-1, and one more to go. VPCs can be PD across. What? Yeah, they can be, but I mean, like, why? 4-1. Okay, my score is 4-1. I will end the video here. Let me know in the comments. Put your score and my score as well, because I won't remember my score by the time I upload this video. So I hope you won this round because I answered one incorrectly. Thank you very much for spending your time here, and don't forget to like and comment. I'm not seeing that many likes and comments to these videos. When you guys do that, that is kind of like encouragement for me to do these things in future, because we don't have a huge audience for this playlist for the projects, etc. But I'm still doing it for few of those who want this. So as an encouragement, if you like and comment, then as an encouragement, I'm like, okay, even those people who are watching, they are really want this playlist to go on. So if you don't do that, then I feel like whatever time I'm spending is not worth the um, you know useful this playlist to others. Instead, I could go ahead and make one that is actually useful to many people, right? So please do that. Otherwise, in future I won't make videos, because I'm making these videos for you guys, and if I don't feel like you guys need it, so it's waste of my time. That being said, thank you very much. Have a great day. See you in the next one. Peace out.